अपुन को मालूम था तुम बहुत खुश होएगा बहुत अच्छा आदमी है अपुन चलता है.
What's up? How are you? Namaste, salam, adab. My name is Harsh and today we are going to continue where we left off. We discuss about linear regression in Hindi, and today, since my friends have asked me to record this video in English, I will be doing it in English. So, as discussed, that there are some data that can be represented approximately by a linear line, and this would be one of those data. So it's a randomly sampled / generated data, and the x-axis would consist of the years from 2008 to 2019, and the y-axis would consist of let's say the price of a particular house. Now, how do we do it? So we actually require 3 libraries to achieve this task, and one of them is matplotlib for plotting and checking whether we did get the ideal line or not. The other is pandas, because this file which I have generated, this particular file, is actually being stored as a CSV on my local computer. So for manipulation and other purposes like loading, extracting one particular row, we require pandas. It makes our life simple, otherwise we have to write the routines for file management basically. So we import pandas and then we import numpy smp. So numpy is mostly for the arrays that we are going to work with, and this is what we had discussed in the last video. And what we basically want to do is, now we would like to extract the x's and the y's. X in our case would be the year, and the y would be the price of the house. Now if you are unsure of how did we get till this point, I would advise actually to go back and review this particular video. Link is in the description, or as you can see currently it's somewhere here. If you are viewing this channel for the first time, please support this channel. Please feel free to like and subscribe on this video. So coming back to our question, so we would like to find a line of the form y is equal to mx plus c, and before that let us load the data set. So we load the data set. So what we do basically is we consider a data frame. So data frame is one of the structures in which the tables are loaded with pandas. So we write pd.read csv, and this is the path. And if you want to check whether your file is loaded correctly or not, then we print df.head. Now by default n is equal to 5. That means the first 5 entries of the table would be printed. So when I try to run this, yes, I get 0 to 4, that is 5. So it's year and price. So it's working fine. But now if you see, it has keys. So year and price are individual keys. So what we do here is we try to plot. So plt.plot, and we have got df here, which is the x, and then df of price, which is our y-axis. And okay, so there's a mistake here. Spot it, and then plt.show. Great. So now when we try to run this, and of course it runs, and it runs well, and it says, yeah, so this is roughly a linear curve, but we would like to actually find the line that approximately passes through these points. But as you saw that we are not getting points, we are getting a plot. So to get the points, we use plt.scatter, which will give us the discontinuous points, and yeah, so we get the points here. So we would like our line to pass through all the points, minimizing the error completely. Now what we want to do from here is we would like to formulate the equation in the form of y is equal to ax plus b. So from the previous video, we have the formulation of the a, b and x. So x is something that we want to find, b is the vector of y's, and a takes the following form. So if you observe that if we have n points, then we have got n cross 2 matrix. So we can define a as np dot zeros, probably, yeah, and then we have n comma 2. Now what is n? N is basically length of df dot year, or anything, like, because the lengths are similar of that particular column vector. B is something that we know is zeros again, and it has the form of, if you see here, it has the form of n cross 1. So we have n cross 1, and then x is np dot zeros, and it is of the form 2 comma 1, because it's just a vector consisting of m and c values. So here we want to find m and c values, right? Now but we have defined zeros here, so are they actually zeros in this case? No, I mean, we still have to fill the values of x's, 1's and y's respectively. So how do we do that? So a, we consider all rows and first column, and we replace the zeros by df year. That's right. And we replace a, and this is 1. So being consistent to this, we change this particular entries to all the x's, and this particular entry, that means this particular column, to 1, and so on and so forth. So now we have to change this to df price. Great, so almost there. Now we just need to formulate this result, something like this. Yeah, so x is given by a transpose a inverse a transpose b. So how do we do it? It's pretty simple. So we have the answer, that is x is equal to, so the first thing is we want a transpose a inverse. So okay, NumPy has a library called linear algebra. So it's numpy.linalg.inv, that is for inverse, and then you have got a transpose a. So we have got np dot transpose a comma a. So it is a transpose a's inverse, and then we have to multiply it with a transpose, np dot transpose a, but we did not really multiply it yet, so it's np dot. Cool. And now we have to multiply it with b, so it will be b, and we still have to do dot. Great. So just to check if we have got the value of x, we try to run it, and yes, we do have the value of x, and this is the value of the slope, and this is the value of the intercepted forms of the y-axis. Cool. Now what do we do with this? We plot it. So what we do is x of 0 becomes the slope, and x of 1 becomes the intercept. So x remains the same. Now we define y, which is, we will be plotting x and y now. So np, this would be just, I think, x of 0, which is y is equal to m into x. So this part becomes the m into x. So this part becomes the x, which is df here, right? Yeah, df here plus c, mx plus c, so which is x of 1. So now what we do is plt dot plot. X is still the same, y has changed. We want to plot it as a scattered line, as a line, dotted line, and color is equal to green. And then we just, yes, we got it. Now what we do not have at this point is a legend, and it will be nice to have a legend here. So let's just say label is equal to scattered points. Great. And let's say plt.x label. So the x's are here, and plt.y label would be the price. And let us just enable here label regressed line, roughly, give or take, and the output here would be plt dot agent. Let's see what's the output like. So we have cleaned it, and yes, so basically this is the price, and this is the year, and this is the regressed line. Now let us go on to the prediction step. So how do we write a prediction step? So prediction is equal to lambda x, or we have already taken x, so let's say b is a singular input to this particular function, and we actually do the same thing what we have done. So x of 0 into b plus x of 1. Okay, so what should be the price in let's say 2030? So let's say we have price underscore 2030 would be equal to prediction of 2030. And so what we can do now is actually we can print the price of 2030. So we can just write print price 2030, and that would be the prediction that we are looking for. And these are the scattered points. This is price. Great. And yes, so 676007, that would be the price of that particular house in 2030. Now I really hope that you loved this video. If you want me to change the narrative somehow and improve upon certain bits, please comment in the comment section, and please do like, share and subscribe this particular video and the channel.